projects. In this video, we are going to explain about the project title, an analysis on financial statement fraud detection for Chinese listed companies using deep learning. Introduction. Financial fraud is a significant issue globally, causing substantial damage to financial markets and stakeholders. Fraudulent activities within financial system involve deceptive practices that can lead to financial losses, erode investor confidence, and disrupt the overall stability of financial markets. Detecting and preventing financial fraud is of paramount importance to maintain the integrity and health of financial systems. Detecting financial fraud poses several challenges, including highly imbalanced data sets, where fraudulent cases are often a minority compared to genuine transactions. This imbalance can make it difficult for machine learning models to accurately identify fraudulent activities. Additionally, the current approaches often have limited utilization of textual information, such as managerial comments or narratives, which can provide valuable insights into potential fraudulent behavior. Overcoming these challenges is crucial for effective fraud detection. The project aims to develop an enhanced system for detecting financial fraud using deep learning models. The approach involves leveraging a combination of numerical features extracted from financial statements and textual data extracted from managerial comments in Chinese listed companies' annual reports. By integrating both numerical and textual data, the system intends to improve the accuracy and robustness of fraud detection. Objective. The primary goal of this project is to create an advanced system capable of detecting instances of financial fraud within Chinese listed companies. Leveraging deep learning models, the objective is to enhance the accuracy and effectiveness of fraud detection in the financial domain. The system is designed to integrate two critical types of data: numerical features extracted from financial statements and textual data derived from managerial comments in annual reports. By combining these two types of information, the system aims to improve fraud detection capabilities. Numerical features offer quantitative insights into a company's financial performance, while managerial comments provide qualitative context and strategic insights. One of the challenges in fraud detection is the highly imbalanced nature of datasets, where fraudulent cases are significantly fewer than legitimate transactions. This project acknowledges this challenge and proposes to address it by utilizing deep learning techniques. Additionally, the project aims to overcome the limited usage of textual information in current fraud detection approaches, recognizing the value it can add in understanding and detecting fraudulent behavior. The project involves a comparative analysis of deep learning methods such as long short-term memory (LSTM) and gated recurrent units (GRU) with traditional machine learning methods. The goal is to assess and evaluate the performance of these deep learning models in detecting financial fraud, comparing them against established machine learning approaches. This comparison helps determine the superiority and efficiency of deep learning models in this specific context. Requirements. The requirements of the project are hardware requirements, in which we have operating system of Windows, processor of i5 and above, RAM of 8GB and above, hard disk of 25GB and above. Software requirements, in which we have Anaconda 3 and Visual Studio Community version. Flow of work. To implement this project, we have designed the following modules. The first module is importing the packages. In this module, various software libraries and packages necessary for data analysis, visualization, and machine learning are imported into the project. Commonly used libraries like Pandas for data manipulation, Seaborn and Matplotlib for visualization, and other specific libraries relevant to deep learning, data pre-processing, or natural language processing are typically imported. This step ensures that the necessary tools and functions are available for subsequent data exploration, visualization, and analysis. Exploring the dataset, fraud detection. This module involves loading and exploring the dataset related to financial fraud detection. Understanding the structure of the dataset, its features, and the nature of the data, numerical, textual, categorical, is crucial. It includes tasks such as loading the dataset into a Pandas data frame, displaying basic statistics, exploring data distribution, and gaining initial insights into the nature of the data to inform subsequent analysis. Visualization using Seaborn and Matplotlib. Visualization is a critical step for gaining insights from the dataset. Seaborn and Matplotlib are widely used libraries for creating various visualization like plots, graphs, and charts. The visualization module involves creating visual representations of the data, which can include displaying sample outcomes to illustrate patterns, trends, or anomalies related to financial fraud. Additionally, creating a word cloud can help visualize common words or phrases in the textual data, giving an idea of the relevant themes. Feature selection using Pandas iLog. Feature selection is a crucial step to identify relevant variables that contribute significantly to the fraud detection model. The Pandas iLog function is often used to select specific columns of features from the dataset based on their indices or names. This module involves identifying and choosing relevant features from the dataset for further analysis, considering both numerical features from financial statements and textual data from managerial comments. Data processing and cleaning. This module focuses on preparing the data for model training. It involves handling missing values, dealing with outliers, standardizing or normalizing numerical features, and encoding categorical variables. Additionally, this step includes merging or joining datasets and ensuring data consistency. Data cleaning is crucial to ensure the quality and reliability of the dataset for subsequent machine learning tasks. Tokenization. Tokenization is a fundamental step in natural language processing (NLP) for dealing with textual data. It involves breaking down the text into smaller units such as words or phrases to facilitate further analysis. In this project, tokenization is applied to the textual data extracted from managerial comments, preparing it for deep learning models that process text as input. Tokenization is essential for creating numerical representations of textual data that can be fed into the deep learning models. Splitting the data to train and test. Splitting the data into training and testing sets is a fundamental step in machine learning model development. The dataset is divided into two parts: the training set used to train the machine learning models and the test set used to evaluate the model's performance. The training set helps the models learn patterns from the data, and the test set provides an independent evaluation to assess how well the models generalize to unseen data. Building the model. In this project, multiple machine learning models are utilized to detect financial fraud. Each model has its own approach and methodology for learning patterns from the data. Logistic regression. Logistic regression is a widely used binary classification algorithm. It models the probability of a binary outcome and is effective for predicting the probability of financial fraud occurrence. Random forest. Random forest is an ensemble learning method that constructs multiple decision trees during training and outputs the mode of the classes for classification problems. It's effective for complex classification tasks. AdaBoost classifier. AdaBoost, adaptive boosting, is an ensemble learning technique that combines weak classifiers to form a strong classifier. It iteratively focuses on misclassified samples, making it a robust choice for classification tasks. SGD classifier. The stochastic gradient descent SGD classifier is a linear classifier trained using stochastic gradient descent, making it efficient for large datasets. It's commonly used in text classification tasks. KNN, K-nearest neighbor, is a simple and effective classification algorithm that predicts the class of a sample based on the majority class among its K-nearest neighbors in the feature space. Decision tree. Decision tree is a tree-like model where each internal node represents a feature and each leaf node represents a class label. It's intuitive and interpretable, making it valuable for understanding the decision-making process. MNB Naive Bayes. Multinomial Naive Bayes is a probabilistic algorithm based on Bayes' theorem. It's commonly used in text classification tasks and is particularly effective for handling features with discrete counts. SVM, Support Vector Machine. SVM is a powerful classification algorithm that finds the optimal hyperplane to separate classes in the feature space. It's effective for both linear and nonlinear classification tasks. MLP, multi-layer perceptron. MLP is a type of artificial neural network where multiple layers of interconnected nodes are used for learning patterns in the data. Each layer processes information and passes it to the next layer, allowing for complex pattern recognition. MLP is powerful for various tasks including classification, regression, and pattern recognition. Gradient boosting. Gradient boosting is an ensemble learning technique that builds multiple weak models sequentially. Each model corrects the errors of the previous one, improving the overall predictive accuracy. It's widely used for regression and classification problems. CatBoost. CatBoost is a gradient boosting library that is efficient for categorical data. It handles categorical features automatically and provides high quality predictions. It's particularly useful for tabular data analysis. Voting classifier. Voting classifier combines the predictions of multiple individuals model, that is logistic regression, random forest, support vector classifier, and predicts the class label by majority voting. This often leads to improved overall model performance. RNN, recurrent neural network. RNN is a type of neural network designed for processing sequential data by maintaining an internal state. It's widely used for various tasks involving natural language processing, time series analysis, and speech recognition due to its ability to capture temporal dependencies. CNN, convolutional neural network. CNN is a type of deep neural network particularly effective for analyzing grid-like data such as images. It uses convolutional layers to automatically and adaptively learn features from the data, making it highly suitable for image recognition and processing. LSTM, long short-term memory. LSTM is a special type of RNN that addresses the vanishing gradient problem, enabling the model to capture long-term dependencies in sequential data. It's widely used in tasks where understanding context over a longer sequence is crucial, such as language modeling and sentiment analysis. GRU, gated recurrent union. GRU is another variant of RNN that, like LSTM, addresses the vanishing gradient problem. It has a simpler structure than LSTM but is still effective in capturing long-term dependencies. It's often used in scenarios where a balance between complexity and performance is desired. Flask framework with SQLite for sign-up and sign-in. Flask is a micro-web framework in Python used for building web applications. In this project, it's utilized to create an interface for user sign-up and sign-in. SQLite is a lightweight relational database management system, and in this context, it's used to store user authentication data for sign-up and sign-in processes. The combination of Flask and SQLite provides a simple yet effective way to manage user authentication within the project. Exploring the dataset. This module involves understanding and familiarizing oneself with the dataset that is going to be used for the project. It includes tasks such as loading the dataset, examining its structure, understanding the meaning of different features, identifying missing or erroneous data, analyzing data distributions, and exploring any patterns or trends that may be present. A thorough exploration of the dataset is crucial for making informed decisions during data processing and model training. Data processing and training model. This module combines two critical aspects: data processing and model training. Data processing involves preparing the dataset for training. This step includes handling missing or null values, encoding categorical variables, scaling numerical features, and possibly transforming the data to a format suitable for the selected machine learning or deep learning models. Data pre-processing ensures that the data is in a clean, consistent, and suitable format for feeding into the models. Model training. Model training involves using the pre-processed data to train the selected machine learning or deep learning models. Training entails feeding the input data into the model, adjusting the model parameters iteratively, and optimizing the model to minimize the prediction errors. User gives input. In this module, the project is designed to accept input from the user. The input could be in various forms depending on the project's requirements, such as text, numerical data, or a combination of both. The system processes and validates the input to ensure it meets the expected format and requirements for further processing. The given input is translated and pre-processed for prediction. Depending on the project's requirement, this step involves translating the user's input into a suitable format for prediction. This includes language translation, if applicable, and further pre-processing to ensure the input is in a compatible format for the trained model. For instance, tokenization and other text processing steps might be necessary for textual inputs. Trained model is used for prediction. The pre-processed input is fed into the previously trained model. The trained model leverages its learned parameters and patterns to predict the outcome based on the given input. The prediction is usually in the form of class label, probability, or some relevant output based on the nature of the project. Final outcome is displayed through front-end. The final prediction outcome is presented to the user through the project's front end, which could be a web application, mobile app, or any other user interface. The prediction outcome is displayed in a user-friendly manner, providing insights or actionable information based on the input and the model's prediction. The front end enhances user interaction and usability, ensuring a seamless and informative experience for the user. Execution. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is model file, which contains algorithm information which will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter Notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the File Explorer. I am copying the path. Open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. I am typing python space app.py. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. Now hit enter. After running the app.py file, the Flask framework will host the application locally at the default address, which is this, and port, which is this. Now copy this local link. I am copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The home page of the project is displayed in the browser. This is the front end built using Flask framework. Now click on sign up button. If we are a new user, we need to register first, but I have already registered, so click on sign in button. So here we need to enter the username and the password which we have created. So I'm entering the username and the password and click on login. This is the home page of the project. So here we need to enter the message, and after entering the message we will predict the financial statement. So I'm entering the message. So here I have entered this message. Now click on predict. So here we can see we got the results for comment. This is the message which we have given. The financial statement is fraud. So this message is the fraud message. Now let us enter some more messages and check whether it is fraud or not. So I'm entering one more message. So here this is the message which I have entered. Now click on predict. So here we can see this is the message which we have given, and the financial statement is not fraud. So in this way, by entering the message, we can predict the financial statement, whether it is fraud or not. The conclusion of the project is, in this point, the project highlights the superior performance of deep learning methods, specifically long short-term memory LSTM and gated recurrent unit GRU approaches compared to traditional machine learning methods. LSTM and GRU are specialized recurrent neural network architectures, particularly effective in processing sequences and time series data. Their ability to capture long-term dependencies in the data makes them suitable for financial fraud detection, compared to traditional machine learning algorithms, which may struggle with capturing intricate patterns and relationships in complex financial data. LSTM and GRU show notable performance improvements, ultimately enhancing the accuracy of financial fraud detection. This point emphasizes the advantage of integrating both numerical features derived from financial statements and textual data extracted from managerial comments in Chinese listed companies' annual reports. By combining these diverse data sources, the system gains a comprehensive understanding of the financial information. Numerical features offer quantitative insights into financial performance, while textual data provides qualitative context. Here, the focus is on the promising classification results achieved using textual features extracted from the management discussion and analysis (MD&A) section of annual reports. MD&A sections often contain critical insights into a company's strategies, risk, and future outlook. Extracting and analyzing these textual features using natural language processing techniques can reveal valuable information for fraud detection. The successful classification results obtained from these features demonstrate their potential in substantially reinforcing financial fraud detection.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.